Hi everybody, welcome back. Happy homecoming. So we have our first video for chapter 3, section 3.2, quadratic equations, zeros, and models. So we have three main ways of solving quadratics algebraically. We can also solve quadratics looking at a graph. But our main three ways of solving it algebraically is factoring, completing the square, and the quadratic formula. And so here are our three methods written out. So we can factor. Now this is not how we factored in CPM. We can use the X box or the distributive property. This is another way of factoring. The completing the square, we'll go over more detailed instructions as a refresher for completing the square in class. And then we have our quadratic formula. Again, this is a formula that you want to memorize. If you don't, my suggestion, go watch the Pop Goes the Weasel quadratic formula song, probably about 5 times. Be sure it's nice and stuck in your head. So we also then have our discriminant. If we look at our discriminant, this tells us how many solutions we can have for our quadratic formula without actually going through the full formula. So if we look at example 1, first off, we have to get it into standard form. So this would be x squared minus 3x minus 6 equals 0. And so then we want to take b squared minus 4ac. If you guys notice, this is the part of the quadratic formula that is underneath the square root. So for this case, if we take b squared, so negative 3 squared minus 4 times our a value of 1 times our c value of negative 6, we get that this is 9 plus 36. So this would give us a positive number, which would mean that we have two different real number solutions. So two real solutions. For part B, if we do our discriminant, so this is negative 1 squared minus 4 times our a value of 2 times our c value of positive 4. So this would be 1 minus 2 times 4 is 8 times 4 is 32. So this would give us negative 31. So then since this is less than 0, this means that we have two imaginary. And then if we look at C, again, looking at our discriminant, we would have negative 6 squared minus 4 times 1 times 9. So this would be 36 minus 36, which gives us 0. So this means that we have one real solution. So looking at our discriminant, this doesn't tell us what our solution is. It just tells us what our solutions, how many and what type of solutions we would have. Now for example 2, we have 3 different quadratics here, and we're going to solve these using the 3 different algebraic methods. So for part A, we have 2x squared minus x minus 3 equals 0. And so for this, we have either the x box or the reverse distribution for factoring. Whichever method you guys prefer, you should end up with 2x minus 3 times x plus 1 equals 0. And so once we have it in our factored form, then we set each of our factors equal to 0. And then we solve those equations separately. So this would be 2x equals 3. So x equals 3 over 2, or 1.5. Or we have x equals negative 1. Now, for completing the square, again, we'll go over the more formal steps of how to complete the square as a refresher. But we want to have all of our x values on the same side and our numbers on the other, so I'm going to subtract 6x from both sides. So we have x squared minus 6x. I'm going to leave a space here that equals 10, and I'm going to have another space. The reason why we have this space is because with completing the square, we want to take our b value, so negative 6, divide that by 2, and square it, which gives us negative 3 squared, which is a positive 9. It's good to write it out this way because this 9 is what we add to both sides of our equation. And so then this gives us 19 on our right-hand side, and then we have concocted this number specifically so that way this left-hand side factors to be x minus 3 squared. So this is always going to be that number before we square it. And so now we have something squared equals a number. And so then this would be, we would take the square root of both sides, so x minus 3 equals the positive square root of 19, or x minus 3 equals negative square root of 19. And so then this would be x equals 3 plus the square root of 19, or x equals 3 minus the square root of 19. And then for part C, we want to use the quadratic formula. This is already in standard form, so this is our A, B, and C value. So we have x equals negative b plus or minus the square root of b squared minus 4 times our a value times our c value, all over 2 times a. And so if you plug this into your calculator, it will give you an error. That means that we have 2 imaginary roots, but we need to find those imaginary roots. So we go through and simplify this. So this is x equals negative 5 plus or minus the square root of 25 minus 32 all over 2. So this would be x equals negative 5 plus or minus the square root of negative 5 over 2. And so remember that the square root of a negative makes it an imaginary number, or we bring out that I. So it's x equals negative 5 plus or minus I square root of 5 over 2. Remembering, so this is a perfect answer for us, but my math lab wants it to separate it into the real and the imaginary parts and have it as 2 different answers. So this would be x equals negative 5 over 2 plus square root of 5 over 2i, and x equals negative 5 over 2 minus the square root of 5 over 2i. So this is how my math lab wants it. So the second page has a bunch of different quadratics, or in the case of f, a cubic. And so go ahead and try solving all of these on your own, keeping in mind that you need to factor out a greatest common factor, which C, E, and D all have a greatest common factor that you want to factor out first. Now for f is a 4 term, and so what we want to do is we want to split this down the middle, look at our common factor between our first 2, and so in this case this would be x squared. Factor that out of our first 2 terms, so then this would be 7 plus 1, or 7x plus 1. And then here, negative 7x and negative 1 do not have any number or variable in common, but they are both negative. So we're going to plot a negative 1, and then this would be 7x plus 1 equals 0. And so we see that what is now in our parentheses is the same factor. So we can factor that out, 7x plus 1. And then our other factor is what is remaining, x squared minus 1 equals 0. Now, we should recognize that this is a difference of squares. So then we can continue to factor to be x plus 1, x minus 1. And then again, we set each of our factors equal to 0 and solve. So we end up getting that this is x equals negative 1/7, x equals a negative 1, and x equals 1. And then we will solve both of these modeling problems of quadratics in class. So leave those for class. Hope you guys have a good time at the bonfire. I will see you all later.